This is a video on arrays in C. An array is a group of variables all of the same data type. Arrays are a very helpful programming tool. In fact, this is one of my favorite lectures to give. I've thought about making a video of this for some time, and now I finally get the chance. So, buckle your seatbelts, get some tight-fitting socks on, I don't want to knock them off, and get ready to find out just how cool arrays really are. Imagine you're at work at a company, and your boss asks you to write a program that will read in two values from the user and calculate and print the average. So you write something like the following. Now I'm hurting on space here, so I've got the comment block and then ... So you're supposed to have your standard comment block with all your includes, your prototypes, your constants and all that stuff in the right order. I just don't have room for that here, otherwise I have to make the font teeny tiny. So just because I don't have it here is not an excuse not to do it. And in the rest of the code examples, I'm actually going to have to leave it out because I don't have space. So it's still there. Just flip on your imagination switch and pretend it is there. Now, also, this particular program example is a little contrived. You'd never write something this simple for business. At least I don't think so. But it does illustrate the point wonderfully. So in this particular program, we have average, total, value 1, and value 2. We print f, tell the user what we want, and then we scan that in. And now, thanks to pointers, when we know what the ampersand means, it means when we read in a integer, we want to store it at the address of this variable in memory. That's where we want to put the value from the user. I often think of it like you order a dump truck full of dirt, maybe for your garden or whatever, and you give them your address and they come and they dump it on your driveway. So that's what the ampersand is, the address of your house. Then we've got value 2. Tell the user what we want, read that in, we add them together, we get the total, and then we divide the total by 2, throw that in average, and print it out. Now some students say, hey, when you want a floating point for average, yeah, we could do that, but that's not really important. That's not what I'm trying to show here. So no sooner have you finished your super cool code and released it to the users that your boss comes back and he says, hey, they love it so much they want you to add in a third value. And so you're like, of course. Alright, so the code for a third value is in blue. You'd have to make a third variable. You'd have to have a third set of printf and scanf. You'd have to modify your total where you add in the third value, and you'd have to divide by 3. Pretty cool, huh? So that's how you would modify your code to work for 3 variables instead of just 2. A few days later, your boss comes back and he says, man, the users are going bonkers. They love your program so much they're wanting it to do 10 numbers. And he's forward thinking, so he goes, I want you to make it work for 100. And you're like, you have got to be kidding me. Well, here is how you would make it work for 100. You'd have to declare 100 single individual variables. Then you'd have to have 100 pairs of printf and scanf. Then you'd have to have this monstrously long total line that adds them all up, and then you could divide by 100 and print them out. Isn't that crazy? Just for fun, I used some Excel magic and actually made the program so you can see just how ridiculous it is. By the way, ridiculous is spelled with 2 I's. So many people do it ridiculous. It's ridiculous. Oh, that's a huge pet peeve of mine. So anyway, so let me show you in Excel how I did this. I did some concatenation magic, and if you had the SQL class from me, you know about concatenating. And I actually made the cell to do that, and then I dragged to get the autofill, and I did that for 100 lines of the variables. Then I made 2 pairs of printf and scanf, did a little divide by action with a row to get my printf scanfs, and then you have to copy those and then paste special, and you paste the values. So here, let me show you that. You copy and then you paste special, and then you pick the values, and that's so you can get the actual result without any formulas. And then I switched over to SQL, I'm sorry, not SQL, into Visual Studio, and I pasted those in. Isn't that crazy? Look at all those variables. Look at all those scanfs. Isn't that nuts? And then look at this huge block of totals where you got to add them all up. Isn't that crazy? Now I did it on, oops, I even made a mistake. That should be plus equals Yeah, I did that on purpose. Yeah, that's it. Seeing if you guys are paying attention. Alright, and since I like consistency and it starts at 0, it's initialized 0, we can go ahead and do that, and then everything all lines up nice and pretty like. So probably the detail-oriented guy in me is wanting to push those over and line them all up. So anyways, isn't that nuts? Isn't that crazy? That's how the program would work. And you know, as soon as you finish that, your boss would come along and say, no, we changed our mind. Make it work for 1,000. So we switch back to our slideshow, and so that's how you'd have to write the code without arrays. Let's take a look at the syntax for declaring and accessing arrays. The syntax to declare an array is just like the syntax to declare a regular variable, but with a few small changes. The syntax to declare a regular variable is data type, space, and then variable name followed by a semicolon. For example, int space int value semicolon. For an array, it's the same thing, but with brackets and a number. So you put data type, then you put the variable name, and then you have hard brackets, and inside a number. So for example, int value, bracket 100, bracket, semicolon. The problem with that is the programmer, that's you, doesn't know it's a group of variables unless he looks at the variable declaration. To make it more readable, we modify the prefix and add an A in front to indicate that it's an array. I also recommend that you make the variable name plural. So for example, we have A int values. So that is an array of integers, and notice the little s, make it plural. That's the equivalent of declaring 100 single variables, int value 1 all the way through int value 100. Isn't that a huge time saver? Very cool. Just like regular variables, there is no default value for variables inside an array. The syntax to initialize the array values, or the array with values, is you put an equal sign, then open curly brace, and then value 1, value 2, value 3, separated by commas all the way out for as many as you need. Now that almost defeats the purpose of making and using arrays. There is a shorthand for initializing arrays, which is you go ahead and declare the array, then you put an equal sign, and then you put one or more values inside the curly braces. Now you just have to enter one or a few values. The last value entered is copied to every remaining element in the array for which a value wasn't specified. So in the above example, it put 0 in the first element of the array, and then it copied that 0 to the other 99 elements. In this example, 42 is entered into the first cell, 0 is entered into the second cell, and then 0, the last value supplied, is copied into all other cells. That would be cells 93 to 100. However, that functionality is compiler dependent. Some compilers copy the last value supplied to the remaining cells, and some compilers don't. Since we are using C for control, there's got to be some limited resource that's pushing us to use this incredibly challenging language. We shouldn't leave it to chance. If we want it initialized, we'll do it ourselves. Let's see how to do that. To change a value in an array, you put the array name followed by index in brackets, and then use the assignment operator to assign a value. So for example, a int values brackets 0 bracket equals 0, and you do it 1, 2, 3, 4, 5 all the way up. Now arrays in C are indexed starting from 0 all the way up to the size -1. So declaring an array of size 100 gives you elements 0 to 99. That's just another little quirk that makes us more valuable because we know all these little geeky things. Now, by the way, that's called zero-base indexing as opposed to one-based indexing. So remember, it's always 0 to the size -1 in C. So I've got the same code here repeated. A int value spot 0 or index 0 equals 0, and so on. Now once we see the brute force code to initialize the elements one at a time, our brains should start shouting, "Hey, use a loop!" because it's the same line repeating over and over. The only thing that's changing is the index value, and that index is changing in a predictable pattern. It starts at 1, goes in steps of 1, and ends at the size -1. So what kind of a loop should we use? Well, it's not breakfast, so we shouldn't be using Fruit Loops. And we know the start, stop, and step, so we shouldn't be using a do loop. So yes, we use a for loop. For example, int index equals 0, we declare a variable, then we go ahead and we make a loop with int index equals 0 while it's less than 100 plus equal 1 every time through the loop, and we replace the hard-coded value in the brackets for the index with our variable index. Ooh. So 100 lines up here have been replaced by 1, 2, 3, 4 lines here, and you can hardly even count the bracketed lines. We could easily change the stopping point to 10,000 or 100,000, and we would still just have 4 lines of code. Sometimes you'll see code like this instead. For int I. What they do is, inside a for loop in the start condition, you are allowed to declare variables. As soon as that for loop is over, the variable that you declared goes out of scope and is gone. So you see this is very common, and of course they abbreviate and they say int I equals 0, I less than 100, and then I plus equals 1, and then they have the assignment operator in the middle. Now, the days of using I, J, K, X, Y, and Z as variables are long gone for you. Why? Because readability is king. C programmers are notorious for writing cryptic code. Sometimes you'll even hear them boast, it was hard to write, it should be hard to read. Well, I don't buy that at all. So for example, you see this line right here, and they of course abbreviated the variable name for the array, and you see this nice little compact code like that. However, if you are paid to write the code, you have a moral obligation to make it readable for the next person, which may or may not be you. So don't do that. To read a value out of an array element, just use it like a normal variable, but with the index in brackets. So for example, printf, the first element value is %d, and then a in values index 0. That's the first element. So to print all values in the array, you do something like this. You have a little for loop here, and you'd say printf value equals %d. And then notice we have index plus 1 and a int values subindex. Now, normally users want to see values 1 to 100 instead of 0 to 99. So when we print it out, we offset it by 1. So that's what the plus 1 is there for. So the users are happy. They don't get confused by seeing this 0 to 99 thing. Now you can also do things like this. Array subindex 5 equals array index 2 plus array index 19 plus 3. That gets 2 values out of the array, whatever's at spot 2 and 19, adds them together along with the value 3, and then stores the whole total back in the array at element location number 5. So you can also read and write to the same element in the same line. For example, a int values, sorry, there should be an S there, spot 7 plus equals 1. That adds 1 to the to the value at the 8th element in the array. Remember, it's 0 based, so 0, 1, 2, 3, 4, 5, 6, 7. So let's go back to our original problem with averaging 100 user values. So you can see I've got 100 variables and 100 pairs of printf, scanf, and one really huge long line, and then divided by 100. We can take care of declaring and initializing all 100 variables with something like this. And the new code is highlighted in blue. I say a int values and 100, and then I have a little loop that just buzzes through those that we just did, and that makes and initializes 100 variables for us. Next, let's use the brute force method of code to read in the values, but with the array instead of single variables. So we've got the double pairs, or the pairs of printf and scanf, and instead of our individual variables, I just use the array elements. Now, as soon as we see it in that format, it cries out for a loop. What kind of loop? It ain't breakfast time, so no Fruit Loops. Alright, even though they would taste good, or some honeycombs. But no, we aren't going to use a do loop because it's changing in a predictable pattern. No, we use a for loop. Here we replace the brute force code with a nice elegant loop, and we've got one pair of printf and scanfs inside the loop that goes from 0 to 100. We %d and we tell the user what number we want to enter in, and we use the +1 trick to offset so the user sees 1 to 100 instead of 0 to 99, and then we read in a value and store it at our array location. And I left it one pair of the brute forced hard-coded ways in there. So notice the hard-coded value of 99 and 100. So that nice little loop takes care of all 200 of those lines. Let's use the brute force code to calculate the total. So here I add it all up. Now I had to leave out some of the codes because it wouldn't all fit on the screen. That's what the dot's for, but we'll bring it all back at the end. So I'd have a really long line, and if you had to type that in, you'd probably tell your boss we need a co-op, especially if it was for 1,000 values. Now I'm going to show you a trick. I'm going to, instead of one long line like we have up here, this really long line, all those values in it, I'm going to divide the code up into several small lines. The functionality will be the same, but it will look different. So we take that one long line and we break it up here, and we say int total plus equals a int values spot 0, and then +1, +2, or plus what's at location 1 plus location 2, all the way up to 99. The code at the bottom has the exact same functionalities above, but once we see it in that format, was your brain screaming, I hate C? No, we need a for loop. And that gives us this. So we've just got a little loop there, and wow, it just adds up all the values. Isn't that cool? Calculating the average is trivial at this point, so we just throw in those last 3 lines, including the comment, divide the total by 100, and print it out. Now remember, please don't say int total equals int total divided by 100. Make the extra variable. There's only 2 reasons not to make that extra variable, and you got to recall what those are. Ignorance and apathy. You definitely can't claim ignorance because I've told you about that. And if you want a good reference, you better not be apathetic. So isn't that amazing? All this code here replaces those 300 lines that we had earlier. And now we know why arrays are so cool, right? So we want to ask, what does Dr. Julius Sumner Miller have to say about that?
Staggering to witness. Staggering.
We're feeling pretty good at this point. We have the code that will handle 100 values, and it's good. Next, our boss comes to us and says, wow, make it do 1,000 values. We reply, sure, it'll take about 4 hours. Just kidding. Never try to fudge numbers with your boss. He will eventually find out, and, bad things happen. If you expect to get paid for 8 hours of work, then you better do 8 hours of work every day. We change 100 to 1,000, and we get this. Perfect, right? So we put 1,000 here, 1,000 here, 1,000 here, 1,000 here. We're done. Nope. Oops. No, it's not perfect. I forgot to change the value down here for calculating the average. Let me ask you a question. Do you think it's possible on a large project with thousands of lines of code that we'd miss it in one spot? Absolutely. How can we fix that? Any ideas? What can we do to make sure if we change it in one spot, it will be changed in all spots? The answer is, how about a constant? So up top in our code, in our constant section, we say constant int array size equals 100, and we use that everywhere. And then if we ever change the constant, it's great. However, because this is C, we got a problem. Whenever you declare an array, you must use a number for the size. You literally have to hard code it in, so you can't use a variable or a constant or even a pound define if you know what those are. It will not work. We still probably want to use the constant everywhere, except when we do the size, we have to literally put in the number. So not a perfect solution, but again, C is a very demanding language. That's just the way it is. That's one of the reasons we get paid so much for doing it. Now later on, we're going to learn how to make dynamically sized arrays, and we'll be able to bypass this restriction. Try to use constant for your array sizes whenever possible. So when, not if, the size changes, you have to update the code in only one spot. So we can do that everywhere we want to loop through the array except when we declare it. Also, try not to use the size in the name of the constant. For example, int size underscore 100. You don't want to have to search and replace all the code in case the size changes, because that would require a name change to match the size change as well. Bad coding. Just have something like generic, like array size, without any number in the name itself. When I give this lecture, some students ask if we could combine the 3 separate for loops into one. And that would give us code that looks like this. So you notice I have one for loop, and inside I initialize, populate, and sum, and then I do my calculations after. I always reply, yes, we could combine the loops. Obviously, I just showed you the code. But I have a better question. Would I, me, Pat Callahan, combine the loops? Now, I make every student write down an answer and, more importantly, the reasons why or why I would not combine the loops. So I want you to write down the answer to that question and the supporting reason or reasons. Please pause the video until you got your answer and the reasons. I'm serious about this. You got to write something down. Putting something on paper makes a big difference. The answer is no, I would not combine the loops, and the reasons why are more important. First off, readability. Second off, simplicity. Try to do one thing at a time, no fancy code. That makes it easier to maintain, change, debug, spot errors, and so on. Third reason, divide and conquer. If it's 3 separate steps, I can assign those steps to up to 3 different coders. As a manager, you divide up work and task your coders with the different pieces of the job. It's important to have that mindset of divide and conquer rather than try to group things together and make it fancy. Finally, the fourth reason, it doesn't really do us any good to combine those loops. It may run a teeny tiny bit faster, but it's not critical for this application, or at least that part of it. I always do speed checks last. My first goal is readability. Sadly, so many programmers put speed first, and they never even really test it any other way. They just think in their mind that it's going to be fast, or this is the fast way to write it, and they never even do any testing. So my goal first is readability. Then, as I run the code, if I discover any slow points, I can examine them. It's real easy to find a slow point. If you push a button on your form and it takes a long time to run, what you do is you put a message box. For example, if it's in VB.net, and you put, step 1. Then a little further down the code, you put a message box that says step 2, and so on and so on. And you time how long it takes between each step. Now, the really fast parts are going to go so fast you close the message box and it pops right back up. However, when you hit the slow spot, there'll be delay between the message box displaying. Real easy. With C code, it's the same thing. You could do a printf. You could say printf step 1, printf step 2. Then you can manually time the time. You can manually time how long it takes to go from one printf to the other, or one printf to be displayed from the other, and then you can find the slow spots. And then when I find my slow spots, 99.9% of the time it's a bad algorithm. I've got, like, for example, a bubble sort instead of a more efficient sort, and I just change the algorithm and wha-bam, no more speed issues. In conclusion, everyone who thinks arrays are cool, please raise your hand. Yes, everyone raises their hand. Yes, they are cool, aren't they? But they could be even more cool. How is that possible, you ask? One word: procedurize. I'm going to show you how to pass arrays to procedures without using pointers. We'll get to pointers when we learn how to make dynamically sized arrays, but we've got to learn how to handle statically sized arrays first. So I'm giving you, there's 2 syntaxes, and I'm giving you the non-pointer one first, and I want you to use that until I specifically tell you to move to the pointer syntax. Here's some sample code of how that would look, and isn't the readability just breathtaking? So in main, I no longer have those different loops. I have initialize array, populate array, calculate array, average, and then I print out the average. That's very cool. Now, I've just done one prototype here. I was hurting on room, and one procedure. So it's a void. That means it's a subroutine. and I pass the array in. Notice I use brackets. What the brackets tell the compiler is instead of a single variable that it is a group of variables, and because it's an array they are all of the same data type. Now basically the array is passed by reference. I know everything is passed by value, but any changes we make will affect the original up here in main. You're going to have to hold off until we get to dynamic arrays to learn why or how that happens. Trust me, you're going to want to enjoy living in ignorance for just a little while. It's a beautiful thing. When we get to dynamically sized arrays, the homeworks are going to be painful. It's kind of like going, right now we're doing the for loop homework where we add numbers 1 to 100, and then the next homework is the pyramid of letters. Well, this right now is the first one. It's just the for loops adding things up. The next one is going to be the equivalent of pyramid of letters, and yeah. So just enjoy it. Just enjoy it while enjoy your ignorance while we have it. So that is an example of how to pass an array. Now you use brackets after the variable name in the declaration and the definition. Sometimes you'll see a number inside the brackets. If you do that, you can pass only arrays of that size. If you leave out the number or the constant, you can pass an array of any size. Most of the time you'll want to leave out the number. So if we go back here, we can pass in an array of any size. Now, because we're using the constant here, that's kind of limited. We're going to develop this and get more advanced, but right now we're going to start kind of with training wheels. Now, you do not use brackets in the call. If you use brackets in the call, it will expect a number between them, and if you put a number between in the brackets for the call, it will pass a single value. So notice up here I have the declaration. There is no number in the brackets in the declaration. Down here in the definition, it's the exact same thing. No number in there that says, hey, I expect to receive a whole group. Now in the call, you don't put brackets at all. That passes the entire array in. Now if I want to pass in just a single value, I would in the call, remember these are both calls, I would put the array name and then a number. Now that will pass a single element from the array into something like print single value. So to recap, use brackets in the definition and the declaration. Don't use brackets in the call. That's pretty much it for arrays at this point. So an array is a group of variables all of the same data type, and I bet you can't wait to get started on a homework to learn or to apply your newly learned knowledge. And that is the end of this video.